Sanchez, and I'm going to explain the limits. I hope you enjoyed the video and understand a little bit about this topic. First of all, what is a limit? A limit in mathematics is the value that a function approaches as the value of the input, in this case x, approaches again to some other value. I know this is not really clear, but later I'm going to explain an example. The basic formula for the limits is limit of f of x when x approaches to a, and we're going to have here the limits. Now we have here an example in a graph. For example, we have the limit of f of x when x approaches to 1. Now we take the value of 1 in x and look for the value that approaches in the y-axis. So we come from the negative side and see that it approaches to positive 1. And we come from the positive side and it approaches to positive 1. It doesn't matter if the value is touching or not, in this case it's a gap, but it's just the value that approaches. So the limit of f of x when x approaches to 1 is 1. And we have the 1 here. Now, the limit of f of x when x approaches to 4. We have here another value, another example, and then the value that approaches from the positive and from the negative side is positive 2. So our limit, that is the value that approaches, is positive 2. But now we have here a different example, and the limit of f of x when x approaches to 2. We come from the negative side and see that the graph ends here in positive 2. And we come from the positive side and the graph ends in positive 3. But our limit in the graph is not the same. So in this case we say that the limit does not exist. Now I'm going to explain the concept of discontinuity. But first, to know what is the concept of discontinuity, we have to know what is continuity. In a graph, the continuity is when it's just like when it's a complete curve or a complete graph. For example, if they're asking the value when x is -1, we see here that the graph is continuous because it is not ending or it's not good. In the discontinuity, we have 3 different kinds of discontinuity. First is the jump discontinuity. The second one is the removable discontinuity. And the third one is the infinity discontinuity. The jump discontinuity is when we have a graph and from one point comes from the negative side, from one point jumps to another point. In the removable, we can have a graph like this, and the point will be in a different side. So we have a gap and a point. And the infinity is when we have an asymptote and there's a graph like this. So one of the values it's going to go to infinity. Now we're going to see the discontinuity in 4 different examples. For example, when we have, they are asking if what kind of discontinuity there are. So when we have x equals 1, so we look for the value of x and 1 and see what kind of discontinuity we have. In this example, we don't have a discontinuity, so we just say that this is a continuous graph. And then when x is equals to -5, so we look for the value of -5, here is it, and look for the discontinuity. We look that we have a gap here and a point in the other side, but the graph is going to the same gap, so we can say that it is going to the same limit, so this kind is removable. Now we look for the value of x equals 2. Here is the value of x equals 2. We look that it comes from the negative side and it stops in 1, and comes from the positive side and it stops in -1. In this example, the limit does not exist because it stops in different sides, but the graph is jumping, so this type is a jump discontinuity. Now, when x is equals to 3, the discontinuity we're going to see here is that x equals to -3. So from the negative side is going to infinity, and from the positive side is going to positive infinity. So in this kind, we know that we have here an asymptote and both sides are going to positive infinity, so this kind of discontinuity is infinity discontinuity. Thank you for watching the video. I hope you enjoy it, and I hope you understood a little bit about limits and discontinuity.